So this is one of the field development planning solutions that we built for Equinor. Actually, this is an area development planning solution. So they asked us to help them optimize the development of an area that involves a number of discovered fields and a number of exploration prospects. This is a subsea development. So their decisions are now, where do we place subsea templates? From which templates do we drill these long horizontal wells, very expensive wells? And how do we connect these templates together with pipelines and gas lift lines and water injection lines back to existing infrastructure, existing pipelines, back to a host platform? A couple of decisions they have to make from an engineering point of view. What sort of drainage strategy do we assume? So depletion or water injection clearly having an impact on the number of wells to be drilled in each of the fields, also the number of subsea flow lines to install. What sort of well complexity do we accept? So high dog legs allow us to drill the wells closer to the target points, but also make them a bit more risky. Now there's a decision around, do we want to standardize some of the subsea templates, or do we allow them to be different sizes? And then a key decision around phasing. So either, now there's two phases to this area development, one in 2025, one in 2029. So do we want to pre-invest into phase two, having quite a bit of uncertainty, but potentially lower cost? Or do we want to phase this investment? So in this solution, you can select some of these decisions. We've calculated those with the results of those with an optimization engine that we've run separately. And we're displaying the results here. So you can make a decision, a scenario, select a design basis, so what well cost or what subsea cost do I want to base my subsea configuration on. We can add the scenario, and here you see the scenario being added. You see a range of volumes associated with this, a range of costs. You can change that to let's say CO2 emissions. You can look at UDC, whatever sort of metric you're interested in. Here you see the resulting map for this particular scenario. This is an optimized concept. So there's 3 6-well subsea templates. There's 1 4-well subsea template connecting pipelines. There's wells and the targets. And you can see these fields within the license boundaries, some of them outside of the license boundaries. A summary of the metrics in terms of total cost, volume developed, CO2 emissions, average UDC. And you see some of the well metrics as well, so the longest well going down to a number of shorter wells. Now you can look at, this is a water injection scenario. Now how would this look like, for example, under depletion, keeping everything else the same? We add the scenario, you can see clearly lower volume, but if we go back to cost, also clearly lower cost, right? Now, how does this look on a map? We need less wells, we don't need water injectors, so we need less templates. And these are again optimized in terms of location, such that total cost, which includes surf cost, as well as well cost, is minimized. So there's an optimization algorithm that has been run separately that leads to these results. And this way you can look at various different scenarios. So you can take out a number of the prospects. So what if these come in dry during exploration? How would that look like? You can see a third scenario popping up, right? So this dashboard allows users and decision makers to look at these kind of different scenarios under an apple-to-apple on an apple-to-apple basis, and that's important. So all of these scenarios have been optimized, so they can be compared consistently. You can compare these some of these scenarios next to each other, just to look at now how different would that subsea configuration be, how different are the metrics associated with each of the scenarios. And this then allows them to, this is a project going to equivalent of DG1 in Shell, so an early phase of the development. But this allows them to make decisions. Now, do we want to standardize on our subsea templates? Where kind of high level, where would these templates be placed? What is the impact of depletion versus water injection? What if some of these prospects come in dry? So what is the impact of, now if my well cost goes up in subsequent maturation of the project, how does this impact my configuration? Does it shorten my wells and therefore give me longer flow lines, or does it remain relatively stable? So this is something we built for them in about 6 weeks. And we also expect to continue to develop the solution as the project matures through subsequent decision gates and towards final investment decision.